last set of notes and we'll be done with section 2.2. You've seen the graphing and the way you can apply transformations to plot parabolas, and now the new calculation of x equals minus b over 2a to give you the x portion of the vertex. Well, now I want to show you how to apply that logic to some of these application problems that you're also going to see in section 2.2's homework. First things first, I just want to show you, how crazy one of these quadratic functions can get. This one's got some really loopy looking coefficients. This function, f of x minus 0.32x squared plus 122.6x minus 13.6. All I want us to do is determine what its absolute maximum or absolute minimum is. So, I mentioned to you earlier that the vertex is the most important point on a parabola's graph. So one level of difficulty in this problem is you first off recognizing that this is a quadratic function. If the highest power of x is x squared, it's quadratic. That means it has a vertex, and depending on whether the parabola opens up or opens down, the vertex will be either an absolute minimum if the parabola opens up, or an absolute maximum if the parabola opens down. So in this case, you're prompted for which one is it? Is it absolute max or absolute min? Well, this particular quadratic function has a negative value of a. And that's your first big, that's really your main clue. Since the a value is negative, this parabola would be opening downward. So when I find its vertex is guaranteed to be an absolute maximum for the whole graph. It'll affect the range. The range will be, minus infinity up to whatever the y-coordinate for the vertex is. So in order to find that absolute maximum, we've got to use our vertex calculation. All right? So there's that formula again. X equals minus b divided by 2a. And keep in mind, there's your a value on the x squared, there's your b value on the x. That's c if you need it for any reason. We just need a and b for our calculation here. So if I run that through my calculation, the opposite of b is negative 122.6. 2 times a is 2 times negative 0.32. That'll be negative 0.64. So let me crunch this one out on the calculator. So, negative 122.6 divided by negative 0.64. My negatives obviously are going to cancel. And that gives me this as the x-coordinate of my vertex. 191.56. If you go to the nearest tenth, it's okay to approximate it. So that's roughly 191.6. Approximately for my x-coordinate. My y-coordinate is found, remember, by taking this x value and plugging it back into the function. So, you definitely want to use your calculator here. What I recommend doing is use the store feature on your calculator. Go ahead and store this as the variable x, and then just type in the calculation of the function. That way it's plugging in that 191.5625 value as x every time you need it. So hit the store button, the one that looks like stow down here. Hit that. On your calculator face, it'll pull up a little answer arrow. It'll store this answer as whatever letter you tell it. And I'm just going to tell it to store it as x. So that way I can type in the calculation from the function right here. Negative 0.32x squared plus 122.6x minus 13.6. And it gives me this as my y-coordinate. It's in the 11,000s. So that's approximately 11,729.2. Again, I'm using the same rounding scheme that I did on the x-coordinate. So this function is a parabola that opens down, and it has an absolute maximum out there on graph paper somewhere at the point 191.6-ish, 11,729.2-ish. And that's guaranteed to be the absolute maximum for the function. Okay. Reason I wanted to show you that example is because most of the quadratic applications that you see in section 2.2 are going to either give you a quadratic model and at some point ask you to determine the maximum this, determine the minimum this, and you'll need to use the model to determine the vertex essentially. But you also got to be able to interpret the results that you get after doing the vertex. This next example is a perfect example from a physics textbook. Anytime you see something subject to the pull of gravity, like a projectile flowing through the air, it's always going to be able to be modeled by a quadratic function. So, in this next example, it's talking about a quarterback that snaps to the receiver. And this function, h of x equals negative 0.04x squared plus 2.1x plus 6.1. What it represents is the actual pass itself. In other words, the flat path of the ball. X, your input variable x, represents the actual horizontal distance away from the quarterback in yards. So you can sort of think of that as values along the x-axis. And then the output values that you get, the y values, represent the height of the ball in feet. So you've got so many x yards away horizontally from the quarterback, and then when you plug that x value in, it tells you how many y feet high the ball is up above the ground level. Okay? So first things first, this is a quadratic function. Let's just find its vertex, because it still fits the pattern. You can use x equals negative b over 2a, plug that back in to get your y, and then that should be the vertex. It's true for any quadratic function, no matter how loopy the coordinate or the coefficients look. So my x calculation, x equals negative b over 2a, negative b, negative 2.1, 2 times a is negative 0.08. And when I crunch that out, 2.1 divided by 0.08 gives me 26.25. So there's the x half of my vertex. The y coordinate is found by plugging that into the function. So I'm going to do the same thing I did in the last example. I'm going to store this as the value x using the store function. And then this is now stored as x. Type in the actual formula for the function, and then it will plug that x value of 26.25 in for you. So negative 0.04x squared plus 2.1x plus 6.1. When I actually plug in that 26.25, it gives me 33.6625. So the answer to the question is, what's the coordinates for the vertex? That's exactly what we just found. The vertex is at 26.25, comma, 33.6625. Okay? Now, this is an application problem, so we've got to actually interpret, in some cases, what that vertex actually stands for. All right, the next couple of questions are going to go deeper in to make sure you understand exactly what these numbers mean. For example, part B, it says, what is the maximum height that the ball reaches? Well, you may have to reread the problem to double check exactly which of these values represent height. Okay? Remember, your x values for this function represent horizontal distance away from the quarterback. That's a horizontal ground distance, so that does not relate to the height of the ball. That x coordinate, 26.25, is just how far away the ball was when it reached the maximum height. The y values of output represent how many feet above the ground the ball is at that point. So when this ball is 26.25 yards away from the quarterback, it has reached a height of 33.6625 feet. And keep in mind, since that's the vertex, that's the highest point. That means that is the absolute maximum that this ball would have reached on its parabolic path going downfield. So the maximum height of the ball is actually asking you what is the y coordinate of your vertex. Just be careful. Remember, this is scaled in yards, and this is scaled in feet. So the maximum height is 33.6, or if you round to the nearest tenth, like I did earlier, you say 33.7-ish feet. And then it asks, how far downfield does this occur? In other words, how far downfield, was it horizontally, I guess in terms of, yard markers, when it reached that maximum height? Well, it was 26.25 yards downfield from the quarterback when it reached that 33.7-ish maximum height. So that's in other words asking for that horizontal distance. How far downfield? About 26 and a quarter. Well, exactly 26 and a quarter yards. Okay. So let's put a picture with this. Just make sure you get an idea of what's going on. Okay. If I actually put this on a rough sketch of graph paper, and I'm not using the entire XY plane here because what you need to think of is the origin is kind of where the quarterback's standing. And then the parabola is going to make a path like this, representing the actual path that the football takes. What we just figured out right here is somewhere around here, 26.25 yards downfield, the ball reaches its peak height of 33.7-ish feet. Right? So in other words, there's my x-coordinate and my y-coordinate for the vertex. The parabola should open down from here. Another point that might be worthy of note, if I plug in x equals 0 into the function up here at the top of the problem, keep in mind what x equals 0 stands for. If I'm at x equals 0, then I'm essentially standing where the quarterback is, or it's where the quarterback is standing. If you plug in 0, all these first two terms wipe out and you're left with 6.1. What that means is at the 0-yard mark, the ball was 6.1 feet up above the ground level. In other words, that's how high it was when it left his hand after he snaps the ball. So that translates as your y-intercept down here. Okay. So if that's my y-intercept, and this is a parabola that opens down, and that's the vertex,
so sorry.
My cameraman just received a phone call, so that's a little tidbit of enjoyment for you. All right.
I hope you enjoyed Cher.
So left the y-axis here at 6.1, reach the maximum height of the vertex, and then eventually is intended to go to the receiver. But if the receiver misses the pass, how far downfield does it actually go? Well, that's what you're looking for. You're essentially looking for the x-intercept of this function. So what I've got to do is use the quadratic formula. So I want to set this equal to 0. And then solve this for x. That should tell me how far downfield, how many yards downfield the ball is going to go when it finally hits the ground again. So it's quadratic. I'm not going to try to factor that, so let's go straight to the quadratic formula. All right. X equals big fraction, opposite of b, plus or minus the square root of b squared minus 4ac all divided by 2 times a. Okay? When you calculate this out, keep in mind you're looking for a positive distance. So you want to use the calculation that's going to give you a positive x value for that positive x-intercept that we've got. The other x-intercept is going to be negative, and that's not going to make any sense for the context of our problem. When you run through this, it's actually going to turn out that you want to take the minus part of the quadratic formula. And when you crunch that out, let's see. The number under the radical is going to be 2.1 squared minus 4 times negative 0.04 times 6.1. So there's my discriminant. I want to take the square root of that. And then, since I want to use the subtraction part, I need to do negative 2.1 minus that value, and then divide it by negative 0.08. You should find out that the ball lands about 55.3 yards downfield. Okay? Alright, that wraps up my examples. So I'm going to go ahead and hit the stop button for today's lesson. There are some other examples I'll work and scan into our D2L page, but I just wanted to give you some, introduction to what the 2.2 stuff is about. So go ahead and crack into that homework and bring questions when you get back from fall break. Have a great break, and I will see you on Wednesday after we get back. Take care.